Howdy folks, this is a combo unit 3.2 and 3.3. Today we're going to talk about roots and fractional exponents. Okay, so we're going to kind of get a mixture of the very first one when we started talking about exponent rules, and then with the radical or rads one where we talk about simplifying radicals and talking about roots. So with that, hey, I keep alluding to this. This is something that, again, if you haven't wrote it down, hint, hint, you should, just because I do think it'll help you, and especially today when we're trying to find out where some have a home between what numbers, it does help. Okay, so we know that 1 squared is 1, which means 1 cubed is 1. 2 squared is 4, times another 2 is 8. 3 squared is 9. And then you take that times 3 again, it's 27, so 3 cubed is 27. 4 squared is 16, cubed is 64. Okay, 5 squared is 25, and 5 cubed is 125. 6 squared is 36, and then if you cube it again, it is 216. 7 squared, 49. Okay, and then if you cube it, it is 343. 8 times 8, all right, 8 squared, 64, and then 512 is 8 cubed. 81 is this, and then I believe it is 729. Okay, the easiest one, 100 and 1,000. And then you got 121, and then 1,331, and then 144 and 1,728. Okay. Good thing to have with you right here to keep with you and to help look back to it. Again, if you can use your notes on the test, why not have it? All right, so let's look at this square, guys. We're trying to find the area of this square. We know that finding the area is length times width. Or, guys, hey, in this case, the formula they use is S squared. So I'm trying to find this length right here. We know that this is the hypotenuse. And so now we know Pythagorean's theorem is a squared plus b squared equals c squared. So I'm going to have 2 squared plus 3 squared. And that's going to give me this squared. Okay, well 2 times 2 is 4 plus, okay, 3 squared is a 9. So that's going to give me 13. Okay, I'm going to square that to get that length. Okay, and does 13 break down? It's a prime number, so it doesn't. So now this is 13. Since it is a square, that means that all of these must be 13. And so, I'm sorry, the square root of 13. My mistake. Okay, and so now we're going to take 13, the square root of 13 times the square root of 13. We all know square root of 13 times square root of 13 is 13. Okay, is 13. So we're not going to explain it because I just did. So there's slide 3. She does a good job explaining it as well. Just remember, she's not from our school, she's not from our district, so if she alludes to state testing and so forth, just know that might not apply to us. Okay, guys, now let's complete the table for the area, for the square, and the units. All right, we see here, so this one right here, the side length is a 1. So what is 1 squared? 1. All right. Now we know then that with this, guys, hey, it's my hypotenuse here. Well, this is one of those 1, 1, so we know that this is the, if you hit this keyboard, hit the keyboard so that it pops up. I don't know why that's not working. Sorry that. I wonder if I have to be out of it here. But there we go. There it is. Okay, maybe I just can't be full screen. Let's move this out of the way. Okay, that's going to be the, gosh darn it, square root of 2. Okay, which means then that, hey, if I find the area, the square root of 2 times the square root of 2 is 2. With C, guys, we see it's an easy 2 units for the side length. So 2 times 2, it's going to give me a 4. All right. All right, so now, guys, on D, let's look at that. I'm going to have a 2 and then a 1, which means this is going to be 2 squared, which is 4, plus 1 squared, which is 1. So this side here, okay, is going to be the square root of 5. Square root of 5, which means in the area, square root of 5 times the square root of 5, I'm going to get 5. And then E, ladies and gentlemen, okay, let's see, I go, oops, sorry about that. I go over 2 units, up 2 units. So 2 squared is 4, plus 2 squared, which is another 4. So that's going to give me 8. Okay, square root of 8. And so then if I know that this is this right here is root 8, then we know that this must be, let's see how we did. We did okay. Hey, there we go, okay? So, all right. There she is explaining it. Let's clear these off. Okay, guys, cube volume, length times width times height. So that means now instead of doing squares, we're going to be doing cubes. Okay, so if my edge is 3, I'm going to take 3 times 3, which is 9, times 3 again, which is 27. Okay, so let's look here. My volume is 27. Now I'm going to look for the cube of 4. That's why I had you write it down, so we know that that's a 64. Okay, so now 8, guys. What cubed is 8? I look at my chart that I've already made, and I see here 2. 2 cubed is 8. And then 7's prime. So we know that, excuse me, we know that that's not it. So what we're going to do then is we've got 7. Okay, get our little keyboard here. And now, guys, instead of a square, I'm trying to get this out of the way. There's just no good place to put it. See where it has the N root? That's the one that we're going to use. And so this spot right here, guys, is where we're going to put the little 3 to signify a cubed root. That's what that is. And then 7. Okay? And hey, when we talk about exact values, guys, a number inside the radical is the exact value. When we get that decimal, you know, they tend to round and those sort of things. Okay? All right. So now, guys, the number, the cube root of 1,200 is between 10 and 11 because we know that 10 cubed is 1,000 and 11 cubed is 1,331. Look at the list to the side and put the numbers in numerical order from least to greatest. We have quite a few here. So here's what I'm going to do, okay? Right now, I'm going to take these whole numbers and we're going to put those in the number line because, guys, these are numbers that obviously, you know, we learned that we know where they go, right? Come up here. Now I've got to fit these rascals in with these whole numbers. Okay, I've got 1 through 9. So, cubed root of 100. If you go back to slide 1, and hopefully you wrote that down, okay, I look at my cubed root and I see what's in between 100. Well, the cubed root of 4 is 64, and the cubed root of 5 is 125, so this has to be within 4 and 5. What about the cubed root of 5? Okay, that has to go here because the cubed root of 1 is 1, the cubed root of 2 is 8, so it has to be somewhere along the lines of there. The cubed root of 50, that falls in between 3 and 4 because the cubed root of 3 is 27, the cubed root of 4 is 64. Okay, so we know that's in between 3 and 4. Did I not do... Oh, I'm sorry, I moved the cubed root of 500. I want the cubed root of... there we go, between 3 and 4. Come on now, there we go. Now, the 500, that one, I look here, 7 cubed is 343. 8 cubed is 512. So this has to be between 7 and 8. And then the last one, guys, 3 cubed root of 10 has to be in between 2 and 3 because I'm mixing all over the place. These are tough to move. That's 2 and 3. That's 3 here. Let's go here. So let's make sure. Okay, this right here, guys, that's going to go in between the 3 and the 4. Hopefully I don't screw that up. Let's try it. Try again. So let's see. Maybe I messed one up. So I've got 1 here. Hey, 3 cubed root. That should be within the 1 and the 2. The 2. And then here we go. 3 of 50. Okay, should be between the 3 and the 4. We got 4, 5, 8, 6. Oh, when I screwed all those around, we should be right there. Hey, let's try that again. Great job. We just did that. So, guys, there we go. Okay, here's her explaining it. And here is the lesson summary. Okay, so basically, guys, just going over, hey, when do I square something? When do I cube something? The 2 key terms that you should realize is with 1, I'm squaring it, so I'm going to take it times itself 2 times. With a cube, think of it as 3D. I have 3 sides, so it will be a cube, okay? Cube. All right. In your own words, what does the square root of 7 mean? Okay, and it's, for me, guys, it is what number times itself gives you 7. That's really a basis of mine. Find the 2 whole numbers that are closest to the cubed root of 22. Okay, I look at my list. We know that it's going to be 2, 2, and 3 because the cubed root of 2 is 8, and I know that doesn't seem close, but it really is in the grand scheme of things, especially with these bigger numbers. And then the cubed root of 3 is 27, so it's in between those 2. So 2 and 3. Okay, warming up. X squared, guys, equals 16. So what times itself gives me 16? There is 2 answers here. That's why it says solutions. 4 and negative 4, because 4 gives me 16, and negative 4 times negative 4 gives me 16. Okay, let's go through these again. Hey, same base, so I'm good. What does A equal? There's no parentheses, so I'm going to add the exponents, 4 and 2. It's going to give me a 6. Okay, when I'm dividing same base, we're going to subtract. So I've got 4 minus 3, so that's going to give me a 1. Obviously, anything that gives me a 1, that means I raised it to 0 power. Anything raised to 0 power is 1. Okay, and now, guys, we also learned that if I have the same exponent, so I have 6 here, we can multiply those bases. So 2 times what gives me 14? 7. And then I look here, guys, what makes 6 into 1/6? That would be a negative 1, because, again, remember, to get rid of the negative, we have to move it across the line. And that's what we did. See? Hey, hey. All right. 14. Another least to greatest. So, hey, let's go ahead. We got 0, 6, and 5. Hey, they're not doing us any favors here. Okay. Radical 30. Radical 30. What square root is in between radical 30? And that would be in between 5 and 6. Because, again, okay, I'm looking at the square root of 25 is 5, and the square root of 36 is 6, so it's right in between those. Cubed root of 27. We know the cubed root of 27 is a 3. It's got to be up here. Cubed root of negative 1. Ooh, that's going to be a negative 1, ladies and gentlemen, because negative 1 times negative 1 is a positive 1. Then you take it times negative 1 again, and you get your negative 1. Radical 14, what's that in between? That'd be 3 and 4. We know that because we know that radical 3 is 9. Radical 4 is 16, so it's in between those. I said 3 and 4. This is a 3. Remember that. Okay, the cubed root of 27 is 3. And then the cubed root of 8 is none other than 2. Okay. Great job. Whew. Such anxiety right before you hit that button. Okay, find the solution, guys, to these. So let's look. X squared equals 25. Okay, I'm going to have a 5, but I'm also going to have negative 5 because I'm using, I don't know why I wrote negative 1, negative 1. I'm using, okay, the equation. So 5 squared can equal 25, and negative 5 times negative 5 equals 25. X squared equals 7. So I'm going to have a positive or a negative. And guys, I'm okay if you do like this, positive sign slash negative. Ooh. Oh, see, it's going to make you, it's math type, so it's going to do that. So if you want, you'll go ahead and you'll give me a radical 7 and then a negative radical 7. And you know what? Here's something that you all should know. You need to space, okay, in between those radicals, or see how that one carried over for me. And I don't know what I'm doing now. Negative radical 7. Y cubed is 8. Okay, we know, so I look at my cheat sheet here, and 8 cubed is 2. Now, it can't be negative 2 because, again, I'm cubing now. So unlike the squareds, if I had a negative 2, that would kick that back to a negative 8. So that's why there's only one answer for that. And then I have the cubed root of 19. And so you're going to do the little one with it. Oops, sorry, you're going to do the one with the little n. Okay, and it's going to show, you're going to make it a cubed root and then 19. Okay? Here's a video kind of going through that. All right, so 17. All right, so Claire said that she knows that 9 squared is 9, and 9 to the first is 9, and 9 to the 0 is 1. I wonder what 9 to the 1/2 means. First, she graphs 9 of x for the whole number of values of x and estimated that 9/2 from the graph. So she graphs the function using the box below. So let's just do this. Y equals 9. Okay, a couple things that we need to notice here. Okay, one is we're going to have an asymptote at the y equals 0 line right here. It's going to come down because, again, I told you there's no way I can have a positive number multiply or raise it to an exponent and get a negative number. So that's why my output is no negative numbers. Also, if you don't manipulate where we're moving it, if there's no translations or anything like that, we know, guys, that anything raised to the 0 is 1. 1, 1, 1, 1, 1, 1. So most of your graphs, too, are going to be coming through this point 0, 1. But that's not what you're looking for. You're looking for at 9.5, where am I at, right? So remember, the exponent is the input. So when I look here, I've got my half, and I come up 1, 2, 3. So we know that it is 3. At least estimate. Okay, so now we know, guys, hey, if I have 9.5 times 9.5, remember what we said with exponents? If there's no parentheses, what do? 1/2 plus 1/2. I'm going to get 1, right? Or you're just going to get 9. 9, so 9 to the first power is 9. And then for that to be true, what must the value of 9.5 be? Oh, sorry. Well, remember, 1/2, okay, 1/2, let's write this down. Gosh darn it, sorry, everybody. 1/2 is the same as writing a square root. 1/3 is the same as writing a cubed root. So don't get fickle when you see the 1/2 as an exponent. So 9 to the 1/2. All right. So in other words, what's the square root of 9? The square root of 9 is 3. All right. There's the video to show you how. Card sort. This can give you an intro, but we're going to do it. Okay. All dealing with sevens, guys. So Let's start with an easy one. 7 to the negative 1. Remember, the negative 1 means I put it in the denominator. So 7 to the negative 1 is 1/7. 1/7. This 343, we know because of our cheat sheet that that is 7 cubed. That's right over here. Okay. 7 squared, guys, is 49. We know that. Okay. Oh, another easy one. 7 to the first power is 0. 7 to the 0. Okay. Hey, how do I get 7? Now that should be 7 to the first power. So there we go. So now I've got all these fractional ones, okay? Now first off, we already said that the square root of 7, that's like saying that you're raising it to a fractional exponent. So 7, the radical 7 is 7 raised to the 1/2. Okay. Which then means that if that's the case, for a cube root to happen, it must be raised to 1/3. And so then like a fourth root would be like raised to 1/4. So you guys got me. You know what I'm talking about. Okay, so now we're just here. Okay, remember, how do I get rid of a negative? I put it on the bottom, so now I'm going to have 1 over 7 squared. 7 squared, 49, so 1 over 49. Okay, and so now, guys, hey, when I have a negative 1/2, that's going to push that 1/2, 7 to the 1/2 down. So now I'm going to have 1. I'm going to have a 1 over a 7 and a 1/2. And we already said that 7 and a 1/2 is a radical, right? So it'll look like that, but a little cleaner. So that means this guy goes with this guy, goes with this guy. Okay, let's see. Now we have these left. Okay, negative goes in bottom. We know that 7 cubed is 743. And so we also know that negative 1/3 is 1 over a cubed root of 7. Let's see. Hey, nice job. We did it. All right. Good job. Okay. You know what? I'm going to go ahead and skip this word problem. Don't really care for it. Here is a lesson summary, kind of going over what we just did. I think this is pretty much in a nutshell. Right here it says we can write a solution to the equation x squared equals 5 two ways, okay? 2 ways. And so using exponents and using radicals, okay? So we know, guys, when I'm using, I want to do b first, okay? Oh, gosh, darn. Here we go. Okay, well, we'll do a first. Okay, I like to do b first. So that means, guys, when I'm here, okay, and I do that, you're going to have a positive square root of 5. And you're going to have a negative square root of 5. Okay, so that's it as a radical. Now, guys, to write that as exponents, we know that the same as radical is something raised to the 1/2. And so for this, guys, it's going to then be a positive 5 raised to the 1/2. And then you're going to have a negative, oh, I'm sorry, a negative 5 raised to the 1/2. Okay? And then write the cubed root of 87 using exponents. Okay? We know this, guys. It's going to be then 80s. What am I on the keyboard? There we go. Okay, we're going to have 87 raised to the 1/3. That's what that would be. Okay? All right, guys, I know I went this quick, but I think you guys have a pretty good, you should have a pretty firm understanding on this. Like I said, hey, I think, you know, the hard days are behind us. The rationals are behind us. We're going on radicals now. I think you understand it. I believe in you. This is going to be a great lesson. I just know. All right. So with that being said, I hope you enjoyed it. Good luck on your classwork. Please reach out if you're needing help. Don't get in a hole. reach out now so we can build those good habits for the rest of the semester. See ya.